Hi, in this video we will see database performance tuning topic, guidelines or factors for creating indexes. So, what is the efficient way of creating indexing? We will discuss. Right. The first thing here is index are used to improve the performance of the database. When we create an index, it improves the search performance. That basic knowledge you might be having. Now, so whether we should create index for each and every column in the table or only some columns in the table, right or not? So if we have large amount of data, we have to create index, or if we are having small data in the table. So like this, we will consider all the factors that will help the DBA in taking a proper decision while creating the indexes. So this is part of the query optimization. This topic is part of the query optimization techniques, because a query runtime or the cost will decrease. The time to get the data from the database and to display it to the user, that time will decrease. So first thing here is avoid indexes on relatively small tables. If the table size is small, that means if the number of rows are less. For example, if a table is having say a few hundred rows or 1000 rows. So if you create an index on a very small table, then it will cause the performance issues. That means it will not give any advantages. The database performance will not improve, but instead it may decrease. Why? Because whenever we create an index, an additional storage structure is required and more IO operations are done. For example, this is our table. Here we are having the columns ID, name, discipline and salary. Suppose if we create an index on discipline table, that is the subject, we can say, or a module, biology, computer science, something like this, we are having data. Now, when you create an index on this column, what database system will do is, it will create a separate structure, additional. This is the additional structure it will do. So when a user writes a query, select from this table, right? Select data from this table where discipline is equal to computer science. So what it will do? It will go to first, database system will go to the computer science table, index table, which is created on the discipline column. Then it search for the computer science value. Then it takes the block address, this pointer is nothing but a block address is available, the memory block address or the hard disk block address available here. It will fetch this value and go to the corresponding records where it is available. Clear? So suppose if we create an index on EMP, what is that, employee name. If you create an index on employee name, an additional structure is created. That means more data or IO operations need to be done by the database system. So here we are having the name. So these names, the unique values will be brought here. Clear? And the corresponding pointer is kept here. So we are having, for example, here we are having some name, that is Crick. So if a user search select star from this table where name is equal to Crick, then what the database system will do? First it will come to the index table, index on name we have created. So it will take the block address from here, in which block of the secondary storage, the hard disk where our data is stored, where our database is available. So it will take this block address and goes to the table. Clear? For example, here we are having the employee name gold. It is available in block say B12. So what is a block? Basically the smallest units in the database, in the secondary storage. In the disk, if the data is in the blocks, these are the smallest storage units, we can say. One block is transferred at a time to memory. So what the database system will do is, when you search or write a query to get the data of the, what is that, user employee name is gold, so it will not come here, because this is a large table, may contain some millions of rows. So first it will come to the small index table. It will search where is the gold record or name available here. Then it takes this block address. Then it will go to the table and search and get this data and take this to the memory to display it to the user. So in this way it will work. Now suppose if we create one more index, on what is that, salary, then additional storage structure is required. So these are the additional structures required where additional data is stored, plus IO operations are needed on disk, which will slow down the performance. So we need to be very careful when creating the indexes. So here the first factor what we have seen is we have to avoid indexes on small tables. Means database can directly fetch from the table itself instead of going to the index and taking the block address and going to the table and bring the data to the memory. So instead of that, it will directly take the data from the table for small table. Second, index the columns that are in multi-table join operations. See, if you are having more than one table, then how we get the data from one table, more than one table? We will write a join condition. What we will do, based on the foreign key or something like that, we will write a query using the join condition. So here I have given a join condition example here. Suppose if you have a query like this, select from table etc., where employee.department number is equal to department.department number. This is an example of a join condition in the query. The columns which are used in the join condition, you have to make index, because these are used in joining the two tables. A column here may be joined with some column here. So that column if you make index, then it will improve the performance of the query, right? Optimization will be good, query optimization. Now the third one, index only if you need to access no more than 10 to 15% of the data in the table. Suppose if you are having a table having say 100,000 rows, if you are having a table which is having rows how many, say 100,000. Now when you write a query, out of 100,000, say 50,000 rows are displayed. User needs 50,000 rows. From this 100,000 row table. Then if you make an index which will bring this 50,000 rows, then that is not a good way. Why? In half of the table anyway you are fetching. Half of the table data is already is required by the user. So why we should go to the index tables, get the block address from there and go to the actual table blocks, then get the data. So that will decrease the performance. So if you need no more than 10 or 15% of the table data, then only we have to make the index. Now we move to the next one, index columns that are frequently used in the where clauses. So search condition, where we write a search condition in the query, in the where class. Now here I have written a query, select star from sales where salesman ID is equal to 2401. That means we are searching on which column? We are searching on the column salesman ID. So when we are searching on the salesman ID column, sales may be consists of some millions of rows with the sales table, right? So if we make an index on the column which is used in the where class, if you make on this column the index, then it will be very useful. The database system will go to the index table, get this block address where this data is available for the salesman ID, and it will go directly to the table. So instead of searching from the 1 million rows, what it will do? It will go directly to the block which consists of this data. Now fifth one, index the column that are involved in order by, group by, and some operations like union, distinct, etc. Why? Because these operations involve sorting, right? So already some data need to be arranged either in ascending or descending. So if you make the index on these columns, because index tables are already sorted, and these operations are also performing the sort, so it will be helpful from the index itself, right? So we have to index the column that are involved in these types of operations. Sorry. Columns that consist of long character strings are usually poor candidates for indexing. For example, if you are having a column in the table, a table having the column say description or remarks, where you are having lot of text information for each row. So now if you make index for this column, that means searching will be on this data. This data is very lengthy, very big strings are involved here. So these are usually poor choices for indexing. So we should not make columns, those columns for indexing where long character strings are available in the data. Now we move to the next point. Columns that are frequently updated. In a table, if a column is frequently updated, it should not be a choice for indexing. Why? Because it involves additional overhead. Additional overhead. So frequently updated columns are not good for indexing. So we have this example again here. For example, if you have a column in which, for example, say salary will not change daily, but consider that salaries change again and again, that means here it should be changed in the table, it should also be changed in the index table, right? If salaries change again and again, it should be done in both places, where in the actual data of the table it should be modified or updated, and also in the index table for salary the data should be modified. Clear or not? So if we choose the column for which the data is frequently modified, we should not use that column for indexing, because it costs additional overhead, additional IO operations, more work for the database systems to correct the things. Now index tables with high selectivity only, that is, choose to index tables where few rows have similar values. That means if the column is having more repeated values, more similar values or duplicate values, we should not do that for indexing. So only if we have the columns which have only few similar values, that is high selectivity table data, then only we should go for indexing for such columns. Now keep the number of indexes small. In a table, if you are having 20 columns, don't make all 18 columns or 20 columns as index. We have to choose only less number of columns for indexing. So it has been shown that, or it has been come to know that a tables with less number of columns that is being indexed performs much better in queries compared to large number of columns if we make index. And one more very important thing is composite indexes. We mostly make indexes on one column, but sometimes if a column is having duplicate values, repeated values, then we will check another column also. That means instead of making one column as index, what we will do is we will make two columns together as index. So if this column has repeated a duplicate value or same value, then if this row has if these two rows have the same values, then it will check the other part. Clear? So here if this row and this row has the same value, then it will check the another column, second column. So such an index where index is created on more than one column. For example, if we make, when creating index on what we can say, name comma locality or something like this. If the name is same, then it will search for the locality. Clear? So in that way, so composite indexes will be useful, but single column values will not have unique or non-duplicate values. So these are the 10 golden rules. So always keep in mind the golden rule of indexing. The index on a table should be based on the types of queries you expect to occur against the database columns, because every application will have its own requirements. Right, every application will have its own requirements. So what type of queries we expect from the users? So those queries, where conditions are mostly the join condition columns, etc. we have to make index. So, these rules if a DBA follows, then it will be definitely helpful in optimization of queries and improving the database performance, because performance is the key. So, that is all in this video. If you have any doubts, do mention in the comment section, right. Do like, share and subscribe to this video on this channel, right. Thanks for watching.